Hello everyone. So today's notes are going to be over arc length and area of a sector. So first off, let's talk about circumference and area because that's essentially what they go along with. So what arc length is it has to do with part of a circle. Or I'm sorry, it should be part of the circumference, right? If I were to ask you to find the circumference of this whole circle, you would be finding the length of the outside, essentially the perimeter of the circle, right? Well, arc length is when you're only finding part of the circumference, okay? And essentially that depends on how much of the circle you are cutting out. So let's say that this was 88 degrees, okay? What you have to do is you're going to use the formula for circumference, which if we recall, circumference is 2 pi r, or we can use diameter times pi, whatever you'd like. I don't know, we'll say that this is 10. However, if we're trying to find arc length, what we have to do is we have to do theta, which theta represents the degrees, over 360 times the circumference. All right, so this here is essentially the fraction of the circle that you're looking at. So for example, with this example that I put here, what we would fill in is we would put our degree measure, which is this right here. We would put the 88 right here. And then you would have to put the radius in, which would go right there. Okay, so essentially it would be 88 over 360 times 2 times pi times our radius, which is 10. All right, so make sure you have this formula written down because this is going to come in handy throughout the lesson. The other thing we're going to be talking about is area of a sector. So we know how to find the area of a circle, right? To find the area of a circle, we have to do pi radius squared. So essentially, we're going to be doing the same exact thing for the area of a sector, but instead of finding the area of the whole thing, we are just finding the area of a small piece of the circle. All right, so again, we're going to be utilizing the area formula, area of a sector, and we're just going to do theta over 360. That represents the fraction that we're looking at, times pi radius squared. All right. So in this example, we would have had 88 over pi, or Jesus, over pi. 88 over 360 times pi radius squared. All right. So that's what we would have done for this example here. So again, make sure you have these formulas written down because they are going to come in handy. So the first type of question you're going to be asked to do on the Delta Math assignment is find the measure of the angle. So essentially what they're doing is they're asking for the measure of this angle in degrees, okay? And it tells you that it represents 2/3 of a full circle. Well, we know that a full circle is 360 degrees, right? So to figure out how much this fraction represents, if it's 2/3 of the circle, we're just going to do 2/3, times 360. And you can do this on your calculator. You just grab this and you do 2/3 times 360. And that gives me 240, and that would be my answer. It would be 240 degrees. All right. That's essentially what we're doing, again, when we are trying to find the arc length or sector area. We have to essentially use that portion of the circle that we're interested in. All right. So now here, they want us to find the arc length of this circle. Okay. So first off, they tell us that QRS, which is this thing here, is equal to 112. All right. And then they tell us that QR is equal to 19. All right. And they want us to find the arc length QS. Now, it is very important to make sure that you're reading these problems because who knows, maybe they'll, slap another letter on here and ask for the major arc or something. You have to make sure that you really read the question and make sure that you're answering what they're asking. In this case, they're just asking for this arc length I highlighted in blue here. So we could go ahead. We're going to use our arc length formula, which is theta over 360 times 2 pi times the radius. So we're going to go plug in our theta, and then we will go plug in our radius. All right, and we're going to have 112 all over 360 times 2 times pi times our r, which is 19. Now, real quick, make sure you pay attention to if they want an exact answer, if they want it rounded. If they want an exact answer, you would just do this, times this, and then slap a pi on there. If they want an exact answer, you're going to multiply them all and just round to whatever they tell you to round to. So in this case, we're going to do 112 divided by 360 times 2 times pi times my radius, which is 19. And I get 37.1406. And they want me to round to the nearest hundredth. So that is 2 decimal places. So I would cut it off here. The 0 tells me to keep the 4 the same, so I just get 37.14. All right, and that would be my answer. Next one. This is another, let's see, find the area of the sector. Oh, okay. So this one is finding area. Sorry, I got too excited there. I think I put them in a different order than I had anticipated, but that's okay. All right, so for this one, they want us to find the area of a sector. So now we have to use our sector formula. All right, area of a sector is theta over 360 times pi radius squared. So let's go right in our information. They told us that LMN is equal to 84, and that LM, which is this guy here, is equal to 18. All right, so we can go ahead and fill all this stuff in. So we're going to put an 84 here for theta. Remember, theta represents the angle. We're going to put an 18 in for r. And this one also asks for the nearest hundredth, so we're going to go ahead and make sure that we just plug this into our calculator. So we're going to do 84 over 360 times pi times my radius squared. And I can do this all on my calculator. Oh, I plugged it in wrong. 18 squared. There we go. And I got 237.5044. And they want it again to the nearest hundredth, so it would cut off right here. That's 2 decimal places. And this 4 tells me to keep the 0 the same. So it's going to be 237.50. And that should be my answer. All right. Okay, next one. Now for this one, they want you to find... They give you all this information. They want you to find the length of GH. Okay, so what you're looking for here is the length of GH. So essentially you're looking for the radius. Okay, and what they gave you was the arc length. They told you that your arc length is equal to 5/3 pi. Okay, and then they also told you that this angle here is equal to 100 degrees. So since they gave you arc length, we're going to have to go use our arc length formula, which is that arc length is equal to is equal to 2 pi r. Okay, so we can go take our arc length and plug it in, and then we can go take our degree measure and plug that in. And I've messed this up too. Wow, I'm like not killing it right now. That's okay though. Hold on. Move that over. I forgot my theta over 360. That's okay. So we do that. We got to put 100 there, and we have to put our arc length in for arc length. So we're going to do 5/3 pi equals 100 over 360 times 2 times pi times r. Now, I'm sure you're looking at this and it looks super duper scary, but I promise it's not that bad. All we're doing here is solving for r. We're trying to find the radius, which will give us exactly what they asked us for. Now, luckily, these pi's cancel. You have a pi on both sides. Those cancel out real nicely. All right, so then we're left with 5/3 equals 100 over 360 times 2 times r. And what we can do is we could plug this into our calculator. All right, and we can get a nice fraction here. We get 5/9 r. Okay, I plugged in 100 over 360 times 2. So this part here became 5/9, right? And then to get the r by itself, we're going to go ahead and multiply both sides by 9/5 by the reciprocal. You could also divide by the fraction, whatever you'd like to do. But essentially, we're going to have to do 5/9, or no, that's not what we have to do. We have to do 5/3 times 9/5. And the reason we do that is so that these cancel and our r is by itself. So we do that. When I plug that into my calculator, I get 3. So my radius is 3. And that would be my answer there. All right. Now let's go ahead and try the next one. So this one, they gave us that POQ. So that's this guy here. He is 72 degrees, so let's go add him in there. And then they tell us that the area of this sector, okay, is 4/5 pi. Okay, so they gave us area of a sector. So we're going to use our area formula, which is theta over 360 times pi radius squared. All right, so we know that the area of our sector is 4/5 pi, and we know that our degree measure is 72 degrees. So we're going to say 4/5 pi is equal to 72 over 360 times pi times my radius squared. Now, we don't know our radius, so we're going to have to just kind of leave that there. And then we can go ahead, cancel out our pi's. We get 4/5 equals 72 over 360. Now, I will say, if you're looking to get some practice with working with fractions, I would highly recommend trying to simplify these in your head. I made my juniors do some of these in their head to kind of get them comfortable with fractions. Feel free to do that. Simplify the fractions, work on multiplying by reciprocals, things of that nature, because this is a really good time to do that. But anywho, we'll go ahead, we'll keep it nice and simple and do it all on our calculator. So we have to get the r squared by itself. So we're going to go ahead and multiply both sides by the reciprocal of this guy. So we get 360 over 72, 360 over 72. So what happens is these guys cancel, and I can now figure out what r squared is. So I'm going to do 360 over 72 times 5/4. Or 5/4, 4/5. I'm really struggling with talking today. All right, so we go ahead and we get that. Then, how do you get rid of something that's squared? You're going to take the square root of both sides. So I got that r is 2. And that would be my answer here, because again, they just asked for OP here, which is my radius. That's what I found. All right. Now, this last one I will say is a little bit tricky, okay? So bear with me here. First, this is an arc. They gave us an arc length, okay? They gave us that RS is equal to 5 pi. Same color. So let's put 5 pi here, okay? And then they told us that QR, which is our radius here, is equal to 6, okay? So that's all fine and dandy. However, what they're asking for is the area of this shaded region. So really, what we're going to have to do is we're going to have to use the arc length formula to figure out this angle. Okay, so let's first figure out what this angle is here. So we know that arc length is equal to theta over 360 times 2 pi r. I've got my arc length of 5 pi. I've got my radius of 6. So I get 5 pi is equal to theta over 360 times 2 times pi times my radius, which is 6. Okay, so then we're going to do what we've been doing here. These 2 pi's are going to cancel. And I'm left with 5 equals theta over 360 times 2 times 6. Okay, now there's a couple different ways you can go about solving this. I'm going to do one that I think is just going to be simplest in your guys' minds. If you find another way to get theta by itself and it works out, I am perfectly fine with that. But what I'm going to do is first divide both sides by 12 to get rid of my 12. So then I end up with 5/12 equals theta over 360. And then to get my theta by itself, I'm going to multiply both sides by 360. Again, there are different ways to do this, and if you want to do it a different way, by all means, go for it. I'm just trying to think of like the simplest way. So what we have here is that we have theta is equal to 150 degrees. So we could go ahead and write that in right here. This guy is equal to 150 degrees. However, they're asking for the arc length over here. If they were asking for the arc length over here, or I'm sorry, not arc length, the area, then we would use the 150, right? The 150, if we used all this information to calculate arc length, it would give us that. However, that's not the shaded area. So what we need to do is we're going to have to do 360 minus 150. And what that's going to do is that's going to give us this angle here, which is 210. All right, so we've got that is 210 degrees. And they asked for the area of that, correct? So we're going to have to go ahead and use the formula for calculating area of a sector. So for area of a sector, we do theta over 360 times pi radius squared. Now we're looking for the area, however we do have our theta, right, which is 210, and we have our radius is 6. So we're going to go plug that in. So we're going to do 210 over 360 pi 6 squared. All right, and that's going to equal our area that we want. And what we can do is multiply this times this. So we're going to do 210 over 360. Oh, I didn't put in parentheses. Times 6 squared. All right, and do they want it? Oh, they want it, okay. And this one, they want it as a fraction in terms of pi. So what we're going to do is we're going to multiply everything around the pi, and we get 21, and then we just slap our pi on. And that would be our area there. So make sure, notice how this one, they wanted a fraction times pi. And in this case, actually, it wasn't a fraction. It ended up just being a whole number. It was 21 pi. But notice, you know, these other ones, they wanted it rounded. It depends on the problem. You have to read the problem to figure out what you're going to do, if you're going to slap the pi in or if you're going to round.